Okay.
Bro, you looking right at it.
All right, everybody.
I got it. You looking right at it, bro. You're being weird.
So, yeah, everybody. Quiz is over. I'll get those graded and done. And probably by Monday. I'll be realistic. It'll be so fun. What I want to go ahead and do now is just, we're going to go over 2 problems from the homework last night, just to make sure we're on the same page. Okay? And then we're going to look at parabolas as a conic section, as opposed to the usual formula. Okay? So first will be the 2 homework examples on circles. Okay? Okay. The first one I want to go over is number 27. Okay? If you remember yesterday, we did a problem where we had to complete, we had to take an expanded problem involving where the circle equation was expanded. We had to complete the square on it in order to get it to be what we're after. This is just one of those problems. I'm choosing it because, though, something neat happened in it, and I just want to show you kind of how it works. Most of the time, though, these are fairly easy problems. And this one's also easy, but I do want to demonstrate kind of the thing it does here. Okay, so plus y squared minus 35 is equal to 0. Okay, so that's my equation. So what I always want to do first is I want to clean it up. I want to try to get all my x's and y's grouped together, and everything that's not an x or a y moved to the other side of the equation. This one has very nicely already been grouped together for me. So all I have to do is just move the 35 over. I'll do that as my first step. Okay. Okay. So that's my first step. All right. And now what I'm going to do is complete the square on the rest of the equation on the x's and the y's in order to figure out what the center and the origin are. So for the x's, okay, what am I going to add on the x part to complete the square there? Plus 1 squared, right? Okay. Now, for the y's, what do I have to add? Huh? 0. Good. Why 0?
Because there's no y, there's only y squared.
There's only y squared. Basically, y squared is already complete. So, in order to complete the squares for it, I don't have to do anything. I just leave it be as y squared. Okay? And that's what I wanted to show you. Then finally, this thing cleans up to be x plus 1 squared plus y squared equals 36. So my origin, my center of a circle, is at what point?
1, 0. Negative 1.
Negative 1, 0. And my radius is at 6, square root of 36. Any questions on how that worked? I mean, it's pretty straightforward. Alright. The next problem I want to look at was from the second set of homework problems. And this is one in which I'm trying to confirm or find points on a circle. Okay? A lot of times, you'll be given an equation with a circle and you'll be asked, is this a point on the circle, yes or no? Or you'll be asked to find a specific point on the circle. In this case, we want to find the x-intercepts and the y-intercepts. Okay. So, what we'll go ahead and do here is we'll take our equation. In this case, we're going to go ahead and do it to, we'll do number 31 here. So our example problem is 31 here. And it reads as x squared, okay, minus 2x, okay, plus y squared minus 6y minus 27 equals 0. So what we want to do is find the x-intercepts and the y-intercepts. Well, this actually is not that bad for a problem like this, okay? Basically, the x-intercepts occur when y is 0, and the y-intercepts occur when x is 0. So if I want to find my x-intercepts first, okay, I set y equal to 0. So for x-intercepts, okay, make y equal to 0. Then we've got x squared minus 2x plus 0 minus 27 is equal to 0. Okay? And now I can treat that like I would any quadratic equation if I wanted to. Okay? Now let's see. What times what gives me 27? 3 and 9. 27 and 1. So nothing. It doesn't factor very easily here. Okay? So what I would do here is either use a calculator or use the quadratic equation to work out my answer. Okay? Remember, quadratic equation says that x is going to be equal to plus or minus b, or sorry, minus b, excuse me, I'm ahead of myself. Plus or minus the square root of b squared minus 4ac all over 2a. So in this problem right here, a is 1, b is negative 2, and c is negative 27. So we're going to have minus 2 plus or minus the square root of minus 2 squared minus 4 times 1 times negative 27 all over 2 basically. We'll go ahead, that's what x is going to be equal to. We clean this up to plus or minus square root of 4 plus 4 times 27. That's 108. Thank you, whoever said that. All over 2, which is 2 plus or minus the square root of 112 over 2. And we can leave our answer like that. So there's 2 x-intercepts. One at 2 minus 112, square root of 112 over 2, 0, and the other one at 2 plus the square root of 112 over 2. Okay, we can leave them like that. Okay? Now, to find the y-intercepts, we're going to do the same exact thing. Okay? We're going to set x equal to 0 this time. So, for y-intercepts, okay, x will be equal to 0. That means x squared cancels out, and the minus 2x cancels out from above, from the original equation. So we'll have y squared minus 6y minus 27 equals 0. Okay, and this one, luckily, does factor. What's this one factor to?
Minus 9 and plus 3.
Y minus 9 and y plus 3. Okay, which means that y is going to be equal to either 9 or 3. So those would be my y-intercepts. Intercepts at
Or negative 3.
oh, negative 3. Yes, sorry. Okay. Alright, but does everyone see how that works? All you have to do is put in 0 for x and 0 in for y to find the intercepts. Okay, so it's a fairly easy task. Okay? That's about it. By the way, if it didn't exist, we would end up with a situation where we couldn't solve it. So like for example up here, if the square root ended up being negative, there would just simply be no x-intercepts. That can happen, it just means the circle goes across the x-axis. Okay? All good? Yeah? Yes, you may use the restroom. Okay. So we're going to move right along then, okay? And we're now going to move to the main topic for today, okay? Which is modeling a parabola as a conic section, okay? So, parabolas as conic sections. Okay, so if you remember, what we're doing here is basically we're essentially going to think of how a parabola works in relation to a cone. Okay, and this gives us a little bit more, I guess, a little bit more things that we can do with parabolas than we're used to. Okay, so first of all, I want you to remind you of the old way. Okay, the old way of dealing with parabolas one of two equations. The first way was the standard form, which was y equals ax squared plus bx plus c. Okay? And then the other way was the vertex form, which was y equals a times x minus h squared plus k. Okay? And those are my two forms of the problem. Okay? Well, what we're going to do basically is we're going to take the vertex form and we're going to tweak it so that it works as for our purposes of the conic section. And there's also two different ways I can write this. Okay? So the new way, based off the vertex form, okay, what we do first is we move the k back over to where y is, and we rewrite it as y minus k equals, and instead of having an a there, okay, we're going to end up with a new term there, 4p. Okay, and we're going to explain what that is in a second here. But it'd be 4p times x minus h squared. Okay, this here, okay, will be referred to as the vertical parabola. Okay, and it's got a vertex at hk, okay, and something new called a focus at h and k plus p. Okay, so that 4p, that p there, is something called a focus now. I'm going to explain here in a second what a focus is. Okay, but that's a vertical parabola. If I tweak this equation, I can rewrite it so it's a horizontal parabola. That is, instead of opening like a U shape this way, it opens more like a C this way. Okay, so a horizontal parabola, okay, would be the horizontal parabola is very similar to this up here. It's 4p times y minus k squared equals x minus h. Okay, so this right here, let me do a separator line here. Oops. Move this down. I want you to move. Why don't you move it? There we go. So this right here is going to be my horizontal parabola. Okay, with vertex at, again, hk, and focus at h plus p. Okay? Any questions there? About what that is? Okay, now I gotta talk about what a focus is. Okay, so I'll let you guys copy this real fast. Do I need to scroll up so you can get the vertical parabola? I'll go ahead and scroll up a little bit. You should be able to see it. Oh, yeah, there we go. Okay, let's talk about focuses and what all this means. Okay, so the focus, plural, is foci. Okay, so a focus, basically what the focus is a point not on the parabola, but kind of inside the parabola. curve, which the parabola bends around, if you will. Okay? So, for a vertical parabola, that's my vertical parabola. My focus would be a point like right there, okay, on the inside. And the idea is, it's not equidistant from everywhere on the curve, okay, but it's about as close as you're going to get. Now, you can think of it almost being like, I'm coming this way, as I get close to the focus, I start to curve around it, and then come back out again, okay? You've actually seen a focus before, okay? The center of a circle is a focus, okay? It's the focus of the circle. The only difference there is, every point on the circle is equidistant from that focus, and so it just ends up going around in a circle, okay? But this one, they're not quite so equidistant, so what happens is they'll bend around the focus instead, okay? Focuses happen all the time. You actually see them pretty much daily. This is probably one of the things that you'll use the most, or use the most in mathematics without even realizing it. Anybody here have glasses? Wear glasses? Okay. The lenses of your glasses, okay, when you're wearing them on your face, they've been designed so that way they focus the light onto your retinas at the proper way. The focus, basically, the distance is actually this right here. It's an actual, when they say focus, that's what they're actually doing, okay? So if you have like a telescope or a microscope, okay, when you focus it, you're changing the distance of the lens so that way they match up and correctly line up for the best picture, okay? So when you focus a camera, when I take a magnifying glass and focus it, all that sort of stuff works this way here. Also, too, if you've ever used a parabolic mirror, so if you've ever seen one of those mirrors that magnify your face, they do that, they're slightly curved inwards, they're parabolic, and the best magnification you get is when you stand at the focus of the mirror, okay? The focal point for all the light in the mirror. So, it is something you see all the time. If you go down to the baseball field, okay, that they play games on, home plate is actually at the focus of a parabolic backdrop. So when pitches go wild, they'll hit the wall, but they generally will pop back right to home plate, which is saved, which is just something that happens here. So that's what the focus's curve is, okay? And so notice how this point here is not on my curve, okay? It's actually inside of it. By the way, if I were to push this so it's actually on the curve, okay, then my basically, it would take it, as that focus gets closer and closer to the parabola will get flatter. So if I actually had the focus touch the parabola would be a flat line. Basically meaning that it takes an infinite amount of distance before it will curve. Okay, so to speak. Kind of an interesting thing. When a parabola opens up this way, the focus is greater than 0. Okay? So it's greater than 0 for a vertical one like this. And for a horizontal one, that opens rightward. Okay? So for these two parabolas, okay, the focus is positive. It's greater than 0. If the focus is negative, that means the parabola is upside down. So when you have a vertical one that's upside down like this, okay, or a horizontal one that opens leftwards, okay, the P is less than 0, okay? Everyone got that? It's pretty straightforward there, okay? But this is all determined again by basically just the equation for parabolas. Any questions there? All right, good. All right, let's take a look at an example or two of how these things work, okay? So what we'll do first is we'll take a parabola and we'll basically kind of graph a parabola from one of these equations for a parabola, okay? So essentially if I had a parabola, let's say I had, we'll make it 2 times, okay, y minus 2 squared equals x plus 4, okay? I'm going to have, where's the parabola's vertex going to be?
2 and -4.
Okay, so it'll be at not 2, -4, -4, 2, okay? It's all right. Basically, think of it this way, okay? Okay, the number that goes with x is always the x-coordinate, and the number that goes with y is always the y-coordinate, okay? So, that's where my vertex is. Now, where's my focus going to be? Okay, it's going to be at what? So, the focus is not 2. Remember, this is supposed to be a 4p here. So, 2 is equal to 4p, so p has to be 1/2. Okay? So, remember, the focus number, the p for the focus number, would be 2 is equal to 4p. So, p is equal to 1/2. Okay? So, question, is this a vertical or horizontal? It's a horizontal one. So, my focus then is going to be at -4 plus 1/2, 2. Okay? That's what my focus is. So graphing this now, I'll come left 4, 1, 2, 3, 4, up 2, 2. There's my vertex. My focus is going to be on that same line, but a half tick away. So my focus is going to be right there. So this is going to correspond to a fairly flat parabola. That looks like that there. Okay? Any questions? Yeah?
How do you know it's horizontal?
I know it's horizontal because it's the y's are being squared. Basically, I've written this as a function of x as opposed to a function of y. Okay? And so when you do that, everything gets shifted, so you can do this for lots of things, okay? But for this one here, this is how it comes out to be, okay?
Why do you add
Because again, this is a horizontal
Oh, yeah.
one, and the focus is always along the axis of the vertex, okay? So that's the axis of my vertex, so my focus has got to be right there, so that's my focus. And in blue here, that's my vertex, okay? If this was a vertical parabola, the focus would be, the focus wouldn't be quite right there, somewhere, but it would be elsewhere. But does everyone see how that works? Okay, shouldn't be that problematic to do. All right, a lot of times though, instead of drawing the parabola, we're going to have the equation for a parabola all worked out, all expanded, and what we're going to want to do is find the focus and the vertex. Okay, kind of like the same way with a circle, where we have it all expanded, we want to find the radius and the origin. Okay, so we're going to take a look at that here in 1 second. Okay, I'll let people copy. Hey, finish my code. What?
He was like not just a dark soda man, man. Like you just love Pepsi, Coke.
Coke, Dr. Pepper.
Pepper's
Okay. Diet Coke, Diet Dr. Pepper.
It's one of those things where they say, is Pepsi okay?
Yeah.
A little bit on the inside.
Okay. I am one of those anti-Pepsi people.
Maybe you don't like. What
Pepsi's
about like
pretty good.
Sprite
I
and
think
stuff?
Pepsi's
Like,
pretty solid.
Huh?
what about Sprite and
Pepsi's
stuff?
very solid.
I'm not
Other
a
colored
big fan
drinks.
of Sprite. I'll drink it on a rare occasion.
Fanta?
Not really.
Sun-kissed, right?
Ginger ale, that's good.
Pepsi
Oh,
products
yeah.
where it's at.
Huh?
Pepsi products are where it's at.
Alright,
That's the truth.
Zero mist?
let's take a look at another example.
I like
So,
Sprite.
in this
Dr.
one right
Dr.
here,
Pepper than potato.
okay, what we're going to do is we're going to find the
Dr.
focus of the
Pepper.
parabola from the given equation. So our equation is y equals 1/2, minus 1/2 x squared, okay, minus x plus 1/2, okay? Hey, what does that look like right there? That looks like the standard form of a parabola, right? Okay. So we're going to treat it like a standard form of the parabola, but we're going to have to go from this form to basically vertex form, and then remember what exactly a focus is, how to find that focus. Okay. So we'll go ahead and we'll start cleaning this up a bit. Okay. First thing I'm going to do is get all my x's on one side and get everything that's not an x on the other side. So I'll rewrite this as y minus 1/2 equals negative 1/2 x squared minus x. Okay? Now what I'm going to do next is get rid of the negative 1/2. Okay, in front of the x squared, because if I'm going to complete the square here, I can't have that be there. So what do I have to multiply the equation by to get rid of the negative 1/2?
2.
Okay, negative 2. Because we also want to get rid of the negative signs as well. So if I do that, I'm going to have negative 2y plus 1 is equal to x squared plus 2x. Any problems there? Okay. Alright. Now I'm going to complete the square on x. What do I have to add over here on the x side to complete the square? Not 0.
Half.
What's half of 2?
1.
1. I'm going to add 1 squared, okay, to both sides of the equation, okay? When I do that, on this side here, I'll have negative 2y, okay, times, excuse me, I'll clean this up. Negative 2y plus 2 is equal to x plus 1 squared, okay? I've completed the square on that side, okay? Yeah?
Why did you move the 1/2 over to the y side in the first step?
Oh, move this over here in the first step?
Yeah.
That was so I could clean up this side here to complete the square on it, okay? Basically, I could have, if I wanted to, I could have left it and gone from there with it, but I would have eventually, since I'm trying to get this to be x plus number squared on one side, I would have eventually had to move it around anyway, okay? Because we don't want this, unlike a regular parabola where it used to be writing it as x plus blah times x minus blah, or x plus blah times x plus blah, we don't want it to look that way. We want it written in vertex form, okay? Which means that this side of it has to be like x plus 1 squared, basically, okay? That's what we get right there. And then I can factor out a negative 2 on the y side here to get negative 2 times y minus 1 equals x plus 1 squared. So where's my vertex going to be then?
Vertex will be negative 1, 1.
Negative 1, 1. Okay? Alright? And now, $1 million question, okay? And this is where things will get tricky. Okay? Basically, the 4p here, okay? Excuse me, I think when I wrote it before, I wrote it, I write it, yeah, I wrote it with the excised. Okay, doesn't actually matter which side it's on, but basically, I'm going to set negative 2 equal to 4p and solve for p. So what's p going to be?
Negative 1.
Negative 1/2. So my focus then is at, okay, negative 1 minus 1/2. Okay? Alright. Did I do that right? No, I think I did that backwards. I got this backwards. Alright.
Do it right. You want me to pause this for,
Yeah.